Welcome to our PowerPoint about the DexOS. This hobby OS was designed by Craig Bamford and a select few other developers. This is by Jake Rhodes and Brandon Thome. This will be a very general spec overview about the OS. It's a 32-bit OS, and he likes to say that it's very similar to the MS-DOS or the Microsoft Disk OS. And from what I can see, it's the commands that it's using is very similar. So when you want to search for a file, you're going to use cd and then the file name dot whatever the file extension is at the end. It's also all the commands for creating a file, deleting a file, moving a file is very similar. And then this operating system is only designed for one processor. So it's a single task operating system however, it can also use multiple threads. So it's nice for multi-threaded programs, just make things faster. And his whole design for this operating system is for it to be fast, efficient, and be kind of like a game console, where it's mainly for programming games. That's his big thing. The language that it uses is FASM, or a very basic assembly language called Flat Assembler that's designed for 86 processors, very similar to the MS-DOS. Now the file extension types, there's two main different types of file extensions that Dex uses, and it's .dex, which is for all your console applications, or if you want to load a program to give you some type of functionality, and then your .gex, and this is for all of your GUI applications. So we'll be showing an example of this at the end of our slides, and it'll show pretty much how the OS works and how you can use it and how the different file extensions work. Now, one interesting thing that I found about it is that it actually uses no virtual memory paging. So as you know, virtual memory paging is just a way or a memory management technique that we can use to help compensate for how small RAM is because it's so expensive. So I was kind of curious because I figured a gaming operating system would want to have, utilize virtual memory paging so that you could not have a limit or a cap on the amount of memory that a program could use. But the pros of not using virtual memory paging would be that you have shorter memory access time, which was a huge thing that Brian wanted to hit on for his operating system, was it to be very fast. And there's also no internal fragmentation when it comes to how it's placing memory. The operating system is only 6 megabytes in size, and it takes up very minimal space in the physical memory. So it kind of makes sense why he doesn't need it, because the amount of memory that's going to be in the physical memory to run this operating system for whatever is necessary is very small. And so you have plenty of room in your RAM to run up whatever program that you would like to run. And the quote in the bottom is just what he said on his website about what he wants the operating system to be, which is optimizing for speed has been paramount of importance. And you'll kind of see that that is generally what he wants the most.
All right, Brandon Thome, modular architecture slide, take 4. So, what we have here that we discovered in the documentation he has on his GitHub, and I'm referring to Craig Bamford, is that he uses a modular design for his operating system, and he definitely does, because at boot time, the executable for the kernel is looking for all of the it's looking for like the hard drives and the drive that you're booting the kernel from, and it's adding them in like one at a time, and then it's looking for it's looking for RAM and detecting that and adding it as well, and then all the applications in the I/O that you could have. So he's using a modular architecture, and it's very easily expandable and all that good stuff. But after doing a little reading in the book, I was thinking it's kind of a mixed approach between having a microkernel and the modular design. Because, as previously stated, this operating system was taking up about like 6 megabytes of space as we were running, and it also has a lot of limited functionality. Like, it's very limited, and um, it's very directed in like what you are like. It's not what you're expected to do, but like what you can do with this operating system. It's very free, as in you can add anything, but you're not going to have a lot of network access and things like that. But as the pros here, is like I was saying, it's just easier to expand or add functionality without changing the kernel. You don't have to come in, like the monolithic designs. It's going to suffer a little bit in speed in that sense, but it makes up for it in a few other techniques, which are explained in other slides. Let me continue on here. Yeah, memory allocation. So what we were reading also in his documentation, that he doesn't have any front-end allocation within the OS, and that's why I was thinking it was kind of a mix between, modular and how a microkernel has to function, is because he shifts the memory allocation duty to the developers, to the app developers, and places that onto the app. Where we were saying that this is less overhead and increased efficiency, but it may actually be a little less efficient. But it's still, in his documentation, he's saying that it speeds up processing just to have the app deal with it. So in a sense, maybe it just increases the throughput of the operating system just to have the app deal with that. However, so what I'm thinking is that, well, it handles it good enough as far as I'm concerned. Let's see. And then,
So this is just going to be a short explanation of the DexOS actually running on our computer. In order to get it to work, we actually had to partition a USB flash drive to where it could hold a max of 4 gigabytes. And the reason for that is because we needed to format it to FAT16. And from in order for FAT16 to work, you have to have a max file size or a max limit on your USB drive of 4 gigs. And then once we were able to format it to FAT16, then we're able to run the application to where it actually download into the USB. And it's super easy to boot the DexOS. All you have to do is plug in USB and then restart your computer and then pull up the boot menu just by, at least for me, it was just pressing F11 and booting it from the flash drive. Other than that, yeah, it was just pretty simple OS to boot up. So I'm going to pass it on to Brandon. Brandon's going to be going over the video, kind of, as you see, like what it looks like, how it runs, how to use the command line, and the GUI or the .gex programs and applications that it has.
all right. Time for the video. Drum roll, please. Okay, I assume you did the drum roll. Okay, here we go. We're going to play now. All right, so what we got here is like right when we boot up the DexOS, it brings up this GUI interface where we can run these gex files. As you can see, they're kind of games. And so what we were reading is that gex files are kind of, they run different GUI applications. Whereas these ones here in the basic driver folder in the hello, those are going to be what's called dex files, and those are going to be like console applications. As you can see, something to run the keyboard, to print, say hello, basic console applications and stuff like that. Here's our reflection, and the guy in the background, that is our photographer with his really nice camera. One second, it's going to focus here. This is where we opened up the command line, and this is where I feel like most of the utility of the operating system comes into play, kind of like was that MS-DOS, how it kind of was back in the day. And as you can see, we typed in help, and it's got a lot of the same system calls that the MS-DOS would, and even the command line does today. You know what I mean? Like it's got the change directory. Um, really, that's the only one I can think of. So, but it's very simple, very basic. As you can see, we pulled the command line, and here we're typing GUI to get back to the first screen here, and that's just the simplicity of this whole operating system. It's like you add your little modules that you'd like to add, like add any functionality, like back, where are we at here? So right here, in my lovely hand, that's me hand modeling, by the way. I don't know if you could tell that. But anything right here, like the basic drivers, folders, and keyboard and stuff like that, you can add your own modules to it. And they'll pop up right when you boot up the program. It'll pop up right into this menu. And it's supposed to be a console-like operating system. And previous versions had better representations of what that would look like. This current iteration of DexOS kind of, I don't know, it just seems very bland and basic, and it kind of steps away from the console-like OS that he was trying to shoot for, but it's gonna just be very basic. And then my hand is covering the Jack stuff real quick. Boom. Oh, focus, focus, focus. You can read it. It's fine. It's a little blurry. But everything like this firework.jx, invaders.jx, everything like that, those are something that you can load from this load program button, I'm assuming, because they're just very basic games and things like that you can code up. And really, that is the entirety of this operating system. And it's a very, as we said, like the very first, there we are again. I'm going to pause on this because that's tradition. There's a good looking Jake. So he is a hobbyist. He's not like a full-time programmer or whatever. And he made this and intended it to be used by like-minded people to just play around with, share code, just kind of like Linux was. It's just very compact, very small, limited utility, and it's been described in like certain articles as a toy, and it kind of is, but it's still very interesting because you can get into the guts of everything. We didn't mention this in the slides, I don't think, but it runs on Ringo, right? So I'm not entirely sure exactly what Ringo is, but it's some sort of JavaScript machine, and it lets you directly affect like the hardware that you're going to use. So like when you're using this operating system, if you're a geek, you can get into everything. Everything's open and available, everything's open source, and everything's free. And it was just kind of fun to learn about. And really, like, it would take you like 10 seconds to look up everything we discovered, and it's actually very nice. I don't know, I really enjoyed this. I really enjoyed learning about this operating system and how different it is from like, something that's mainstream. Like if you aren't a programmer or something like that, you're not going to find use out of it. It's like written in FASM assembly code, so it's just super interesting. And that is the end.